Okay, this is the last thing for Module 2B. Today we're going to take a look at identifying and converting between standard, intercept, and vertex form. And once we do that, we're also going to graph these quadratics. Okay, so remember the graph of a quadratic is called a parabola. And there are three forms of quadratic equations. These first two we should already be familiar with. This first one is called standard form. And remember, this number at the end is the y-intercept. So that's the easiest point to identify. You don't have to do any work. You can just look at the equation. That y-intercept will be 0, comma, whatever that constant c is at the end. This next one we call vertex form. So guess what point's going to be easy to identify? The vertex. And remember, that does come from the h and the k in the equation. The one thing to remember about the h, it's the opposite of what you see, because notice the equation has a minus in it. This last one is new for you. I usually call it intercept. Another way to refer to it is like factored form. It's what we've been doing this unit. So the thing we can identify here are your x-intercepts. So there's going to be two of them, this p and this q. Once again, notice it is the opposite because it's subtracting. So p comma 0 and q comma 0 will be your x-intercepts. Okay, I put a little note here. When you're converting between all three forms, now that we've worked through completing the square, right, and expanding and simplifying, we've rehearsed all the conversion tools we need to move back and forth between the three forms of a quadratic. Complete the following graphic organizer as a way to summarize the conversion. So, standard form is going to be the center. If we're going from standard to vertex form, we are going to complete the square. If we're going from vertex back to standard, we're simply going to multiply and simplify. Okay. To get from standard to intercept form, we are going to factor. And then from intercept back to standard, once again, you multiply. And if you can, you simplify, right? So we are going to practice those skills. So the first one they give us is something, this is in vertex form, right? This first one's in vertex form. So the first thing we're going to have to do is convert it to standard form. In order for us to do that, we are going to have to multiply. So f of x equals 2 times x plus 2 squared minus 18. Okay, I'm going to teach you a little bit of a new way to multiply. So I'm going to put a little side note here. So x plus 2 squared, we know that's the same as saying x plus 2 times x plus 2. I think that you should always rewrite those, because otherwise you forget to multiply it times itself. You'll just like distribute the squared in, and you kind of forget some terms. You can still totally distribute if you want, and you like that. I'm going to show you another way to do it. Kind of goes along with the pictures that we've been drawing. If you just write x plus 2, and then the other side is also x plus 2, we can make a 2 by 2 box and just come up with the terms that way. So x times x is x squared, 2 times x is 2x, 2 times x is 2x, 2 times 2 is 4. So these two terms in the middle we can combine. So we'd have x squared plus 4x, because we had 2x plus a 2x plus 4. And if you find that easier to organize your work, you're welcome to draw that little box rather than distributing. Okay, so now let's write what we found out. We've got f of x equals 2. We now have x squared plus 4x plus 4. We still got a minus 18. We are now going to have to multiply the 2. So we get 2x squared plus 8x plus 8 minus 18. So our final answer here, as we simplify, we get 2x squared plus 8x minus 10. Okay, now that we have it in standard form, we can go ahead and factor it to put it into intercept form. So we've got 2x squared plus 8x minus 10. Remember, with factoring, the first thing you always want to look for is a GCF. So I see a 2, an 8, and a 10. Each of those have a GCF of 2. I can factor 2 out. So I'd get f of x equals 2, parentheses. When I divide 2x squared by 2, I get x squared. 8x divided by 2 is 4x. Negative 10 divided by 2 is negative 5. So I'm looking for what multiplies to negative 5 and adds to 4. In this case, I have a positive 5 and a negative 1. And since there is no number in front of the x squared now, right, we factored it out, I can use my shortcut. So we're still going to have a 2 out front, but my two factors are x plus 5, x minus 1. Okay, let's look at each of these and decide those key points. So this first one, right, it tells us your vertex. So we've got the opposite of a positive 2, so it's going to be a negative 2. And we've got the y value of negative 18. Okay, standard form, which is the one down here on the left, tells you your y-intercept, which is negative 10, so 0, negative 10. This factored or intercept form tells you your x-intercepts. So we do have a positive 5, and we've got a negative 1. So the only thing you got to remember, just like with the vertex, is the opposite. So it's the negative 5 and a positive 1. From there, you probably have enough to go ahead and graph it. So let's see, if I plot my x-intercept at negative 5, and at 1, my y-intercept at negative 10, I should have made this graph a lot larger because technically my vertex is all the way down here. We get something like this, right? And it should be symmetrical. Okay, well done. Let's look at the next one. So on this one, we're going to start again. This is currently in standard form. So to convert it to intercept form, we're going to factor it. So to factor it, we're saying, okay, what multiplies to negative 8 and adds to negative 2? We've got a negative 4 and a positive 2. Since there is no number up front, we can use our shortcut, x minus 4, x plus 2. Okay. For this next one, do you guys remember completing the square? So we do like, hey, x squared, I'll just write the original equation. And then we're going to write an equation, the first two terms, and I want to just know what completes that. So if I take negative 2 divided by 1 and I square it, I get negative 1 squared and I get 1. So I'm going to add 1. But remember, we have to say, okay, well, these are not equal right now. So how do I get from 1 to negative 8? I'm going to subtract 9. Now those equations are equivalent. And I can rewrite these first three terms as x minus 1 squared. And if it's helpful for you, you can't even think about the factoring now. Like what multiplies to 1 and adds negative 2, it's a negative 1 and a negative 1. Or you may just know from this unit, hey, I knew what format those always took. Okay. So let's start. This first one was standard form, and it told you your y-intercept. So that's 0, negative 8. This next one was intercept form. That tells you your x-intercept, and it's the opposite. So it's a positive 4 and a negative 2. Your vertex, the opposite of the x, so a positive 1, but it stays as negative 9. Okay, let's plot those points. Positive 1, negative 9. Negative 8, and then you also have 4 and a negative 2. If it's helpful for you, remember this axis of symmetry will go through that vertex. So it will mirror on the other side if you wanted to like plot another point kind of across from the y-intercept. Okay, one more. On this one, the first thing we're going to do is convert it to standard form. So we're going to go ahead and multiply it out. If you like distributing, go ahead and save that. I am going to show you that box again in case you like that method better and you find it easier to organize your work. We've got x plus 2 and x plus 6. X times x is x squared. 2 times x is 2x. 6 times x is 6x. And 2 times 6 is 12. These middle terms can be combined, so we'd have x squared. 2x plus 6x is 8x plus 12. So this is f of x equals. Okay. To find your vertex, we're going to take what we had in standard form. And remember, we're going to write the perfect square trinomial with those first two terms. So we're saying, okay, what completes that square? So you're saying, hey, if I take 8 and divide it by 2 squared, I get 4 squared, right? So that's 16. So I'm going to add 16. But remember, these are not equal right now, so you say, okay, well, how do I get from 16 to 12, I subtract 4. We can now rewrite those first 3 terms, this part, as a perfect square trinomial, which is x plus 4 squared minus 4. Okay, let's go through. This first equation is in intercept form, meaning your x-intercepts. So let's go through. We've got a positive 2 and a positive 6, so it's the opposite. It's a negative 2, 0, and a negative 6, 0. This next one, a standard form, has the y-intercept, which is 0, 12. The last one, a vertex form, is the opposite of the 4, so a negative 4, but the y stays the same, so a negative 4. Let's plot those points. Negative 4, negative 4, negative 2, negative 6. And your y-intercept's off the graph, and that's okay. We have enough to know what this parabola looks like. Good luck with the assignment.